Please see the 18th question. A square minus B square. A square minus B square. It is 101. A comma B belongs to natural numbers. Find A square minus plus B square. First catch in the question is 101. It is a prime number. 101. It is a prime number. 101. It is a prime number. So these A plus B into A minus B. A plus B into A minus B is 101 has got only two distinct factors. 101 has got only two distinct factors, that is 1 and itself. That is 1 and itself. So these is nothing but 101 into 1. Don't write it as 1 into 101. That is mathematically incorrect. Why? Because if A and B are natural numbers, if A and B are natural numbers, A plus B is always greater than A minus B. So if A plus B is, if A plus B, Praveen, pen jodu, right? A plus B equivalent to 1, 101. A minus B is equivalent to 1. 2A equivalent to 102. If 2A is equivalent to 102, A will be 51 and B will be 50. So answer for this question is 51 whole square plus 50 whole square. So these is nothing but 51 whole square is 2601 plus 2500. Answer for this question is 5101. Sri Shailam, I am not understanding. Sir, n is divisible by 9 or not. Which question you are referring? Please WhatsApp me after the class. Right? WhatsApp me after the class, beta. Right? A plus B into A minus B is 101 into 1. Don't write it as 1 into 101. Why? Because if A and B are natural numbers, sum of two natural numbers is greater than their difference. So A equivalent to 51 and B equivalent to 50. 51 whole square plus 50 whole square. Answer is 5101. How to write these 51 whole square as 2601 directly? Please write down a concept. Square of the numbers. I discussed this, but I will repeat it. Square of the numbers from 35 to 75. Square of the numbers from 35 to 75. 50 plus x whole square equivalent to. I have given you the proof for this concept in my previous sessions. Please watch the previous sessions for the proof. 50 plus x whole square equivalent to 25 plus x slash x square. X square should be in its 2-digit format. 51 whole square is 50 plus 1 whole square. X is 1. 25 plus 1, 26. 1 square is 1. 1 in a 2-digit format is 0, 1. Similarly, if it is 59 whole square, which is 50 plus 9 whole square, x is 9. 25 plus 9, 34. 9 square is 81. Suppose if it is 48 square, x is minus 2. 25 minus 2 is 23. 2 square is 4, which is nothing but 04. Suppose if it is 63 square, 63 is nothing but 50 plus 13 whole square, x is 13. 25 plus 13, 38. 13 square is 169. 69, 1 carried. Answer is 3969. How to find out the squares from 35 to 75? This proof is present in my previous sessions. Please watch the previous sessions to understand how it is 25 plus x slash x square. 50 plus x whole square equivalent to 25 plus x slash x square. I hope the concept is clear. Kindly reply in the live chat if it is clear to you. Is it clear to you? Is it clear to you? Kindly reply. 18th one. 19th question we will solve. Everybody kindly reply, sir. 18th one. 19th one. For how many prime numbers values is p square plus 3p minus 1 a prime number? Concept. What is the concept we are going to use? Any prime number greater than 3, it is of the form 6k plus or minus 1. This is the concept which we are going to use. So, let us take a prime number p here, prime number p here, and let us take p square plus 3p minus 1. The lowest prime number is 2. So, this will become 2 square plus 3 into 2 minus 1. 4 plus 6 minus 1. 10 minus 1 is 9. 9 is a composite number. Next it is 3. So this will become 3 square plus 3 into 3 minus 1. 9 plus 9, 18. 18 minus 1, 17. 17 is a composite number. Next prime number, it is 6k minus 1. If it is 6k minus 1, 6k minus 1 whole square plus 3 into 6k minus 1 minus 1. This is nothing but 36k square minus 12k plus 1 plus 18k minus 3 minus 1. This is divisible by 3. This is divisible by 3. 18k is divisible by 3. 3 is divisible by 3. 1 minus 1 is also divisible by 3. Any prime number which is of the form 6k minus 1, it is divisible by 3. It is divisible by 3. Next prime number is 6k plus 1. If I take 6k plus 1, this will become 6k plus 1 whole square plus 3 into 6k plus 1 minus 1. If you open up the bracket, 6k whole square divisible by 3. 2 into 6k divisible by 3. 3 into 6k divisible by 3. 3 ones are 3. 1 minus 1. It is also divisible by 3. Any prime number greater than 3 is of the form 6k plus or minus 1. This is the usage. This is the usage. Any prime number greater than 3, it is of the form 6k plus or minus 1. First take the lowest prime number 2. Next take the next prime number 3. Any prime number greater than 3, it is of the form 6k plus or minus 1. Only thing what we have to do it is to check for 2, 3, 6k minus 1. If you substitute it, just in the expression itself I am able to see 6k whole square. So it is divisible by 3. 2 into 6k divisible by 3. 3 into 6k divisible by 3. 1 minus 1, it is divisible by 3. Another good level. Now we are increasing the level, sir. Intermediate level questions. Answer is, how many prime numbers does this number is a prime number? The only prime number which makes this number a prime value a prime number is p value 3. Answer is 1 value. 20th question. Now here onwards, listen carefully, sir. I am increasing the level of difficulty. Increasing the level of difficulty. For how many values, prime number values, p is p square plus 15p minus 1, also a prime number. If p is 2, this will become 2 square plus 15 into 2 minus 1. This is 4 plus 30 minus 1. 34 minus 1. 33. 33 is a composite number. Next prime number 3. 3 square plus 15 into 3 minus 1. 9 plus 45 minus 1. 54 minus 1, 53. 53 is a prime number. Any prime number greater than 3, it is of the form 6k minus 1 or 6k plus 1. 6k minus 1 whole square plus 15 into 6k minus 1 and minus 1. 6k whole square divisible by 3. 2 into 6k divisible by 3, 15 into 6k divisible by 3, 15 divisible by 3, minus 1 whole square, plus 1 and minus 1, these cancelled. Answer is divisible by 3. Answer is divisible by 3. Any prime number greater than 3, it is of the form 6k plus 1 also. 6k plus 1 whole square plus 15 into 6k plus 1 and minus 1. 6k whole square divisible by 3. 2 into 6k divisible by 3. 15 into 6k divisible by 3. 1 minus 1 cancelled. 15 is divisible by 3. How many prime values it will take? P equivalent to 3. It is not only one value. Do in this step-by-step process. The lowest prime number is 2. Next prime number is 3. Any prime number greater than 3, it is of the form 6k minus 1 and 6k plus 1. I hope the idea is clear. I hope the idea is clear. 19th and 20. Now see here. 21st. Another good question. What is the largest prime number whose cube divides 1001 factorial, 1 factorial into 2 factorial into 3 factorial and so on up to 997 factorial, 998 factorial, 999 factorial, 1000 factorial and 1001 factorial. What is the question? What is the largest prime number? In this entire set, we have to find out the largest prime number. We have to find out the largest prime number. How to find out the largest prime number? Come from the right hand side. 1001 is 7 into 11 into 13. 1001 is not a prime number. 1000 is not a prime number. 999 is not a prime number. 998 is not a prime number, because either one number is an even number or it is divisible by 3 or 7, 11 and 13. 997 is the largest prime number. 997 factorial. This is nothing but 997, 996 and so on up to 1. Here 1 power of 997 is present. 998 factorial, it is nothing but 998 into 997 and so on up to 1. Here another power of 997 is present. 999 factorial, which is 999 into 998 into 997 and so on up to 1. Here also one more 997 is present. So cube should divide. Here it contains ones. Here it contains second. Here it contains third. Here it contains fourth. Here it contains fifth. Right? So I will get total 997 power 5. Is 997 power 5 divisible by 997 cube? Yes. Answer is largest prime number is 997. Largest prime number is 997. We require largest prime number. Come from the right hand side. Come from the right hand side. 1001 factorial. 1001 is a composite number. 1000 is a composite number. 999 is a composite number. 998 is a composite number. 997 factorial, it contains 1 power of 997. 998 factorial also contains 1 power of 997. 999, it also contains 1 power of 997. 1, 2, 3, 4, 5. 5 powers of 997 is present in these 5 numbers. But I want cube. 997 power 5 is always divisible by 997 power 3. Answer for this question is 997. Answer for this question is 997. I hope it is clear. You can also cross check whether 997 is a prime number or not by using the square root rule. Take all the prime numbers less than square root of 997. 31 square is 961. So take all the prime numbers, none of the numbers divides 997. So answer is, it is a prime number. Answer is 997. I hope 21st question is clear. 22nd. Another question. Sum of, this is a very easy question. A, B, C, D and E. These are 5 prime numbers. Sum of these prime numbers is 264. A1, A2, A3. Yesterday night we have discussed A5. It is 264. Sum of these prime numbers. So if I take it as odd, odd plus odd, plus odd, plus odd, plus odd, odd plus odd plus odd plus odd, odd plus odd even, odd plus odd even, even plus odd is an odd number. But the right hand side is an right hand side is an even number. That means all the 5 cannot be odd. One has to be even. One number 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 has to be even. What is the smallest number and it is even? A value 2. So 2 power 5 is 32. Answer for this question is 2 power 5, 32. Similar question, we solved it in the yesterday's class. There are 5 numbers whose sum is 264. Right hand side is an even number. All the 5 numbers sum, it should be an right even number. All the 5 cannot be odd. One has to be an even number. 22nd. Now, please put a star mark on this question. This is a previous year CAT question. Previous year CAT question. Now see here, read the question. Find what is the number of natural numbers in the range of 2 less than n less than 20. Okay. N minus 1 factorial. N minus 1 factorial is not divisible by n. Is not divisible by n. N minus 1 factorial, when divided by n, remainder is not 0. Remainder is not 0. The range is starting from 2 to 20. Let me take n value 3. N value 3 is 3 minus 1 is 2 factorial. 2 divided by 3. It is not 0. Let me take n value 4. So this is nothing but 4 minus 1, 3 factorial divided by 4. 3 factorial 6. 6 is not divided by 4. Let me take n value 5. 5 minus 1, 4 factorial. 4 factorial divided by 5. 24 is not divisible by 5. Right? If I take n value 6, if you observe, 6 minus 1 is 5 factorial divided by 6. 120 by 6 remainder 0. That means what is that I got? I got 3 is a prime number, 5 is a prime number and 4 is an exception. All the prime numbers from 2 to 20, all the prime numbers from 2 to 20 including 4. Including 4. 4 is one number which will not give a remainder 0. All the prime numbers from 2 to 20 including 4 will satisfy this condition. What is the condition? N minus 1 factorial is not divisible by n. N minus 1 factorial is not divisible by n. So that means 3 is the answer, 5 is the answer, 7, 11, 13, 17, 19 and the next one is 4. So total values are 1, 2, 3, 4, 5, 6, 7. Total values are 7. If n minus 1 factorial is not divisible by n, if n minus 1 factorial is not divisible by n, it is nothing but all the prime numbers including 4. All the prime numbers including 4. From 6 onwards, what will happen? 6 minus 1 factorial, 5 factorial by 6. 120 divided by 6 is 0. N value 7. 7 will become 6 factorial divided by 7, it is not divisible. You will get every prime number. The only exception is n equivalent to 4. All the prime numbers from 2 to 20 including 4 is the answer for this question. Next one. Please see here. It's a another beautiful cat replica question. Each of the 3 friends, there are 3 friends, F1, F2 and F3. Each of the 3 friends independently think of a number. Which is nothing but the product of 2 prime numbers. So I will think of a number which is nothing but product of 2 prime numbers. Each and every number is nothing but a product of 2 prime numbers. 2 different prime numbers. Which of the following could be the product of 3 numbers? Slash into slash into slash. What will be the answer? If no 2 persons think of the same pair of numbers. If no 2 people are thinking same pair of numbers. There are 3 friends. F1, F2, F3. F1 is thinking about a number. F2 is thinking about a number. F3 is thinking about a number. That number is a product of 2 different prime numbers. Now, see here, I will F1, F2 and F3. Now see here. Suppose if I take, first I will take this, then I will take another. 121 followed by 3 zeros. These are nothing but 121 into 10 square. 10 square, I think it is 2 zeros. There is a calculation. These are nothing but 11 square. 10 square is 2 square into 5 square. 2 square into 5 square. This is nothing but, first one thinks about a number which is the product of 2 different primes. I can take 11 into 2 here. Another one, 11 and 2 is over. Another one can think 2 into 5. Another one can think 11 into 5. What is the multiplication of all these 3? 11 into 11 is 11 square. 2 into 2 is 2 square. 5 into 5 is 5 square. Each one is thinking about a number which is nothing but product of 2 different primes. Product of 2 different primes. It is only 1 zero, sir. 2 zeros. 1 zero is eliminated. Sir, why 120 cannot be the answer? If it is 120, it is 2 cube into 5 into 3. 8 5s are 40, 43s are 120. So, 2 cube, try to arrange it. Each has to be written. If I take 2 into 5 here, 1 2 into 5. If I take another 2 into 3 here, 2 square is gone. What is another remaining? 2 power 1. But it should be written as a product of 3 prime numbers. 3 prime numbers. So 120 is incorrect. Suppose if it is 144, which is 2 power 4 into 3 square, 16 into 9. If it is 2 power 4, I can first give product of 2 prime numbers, 2 power 1 into 3 power 1. Next I can give 2 power 1 into 3 power 1. Next will be t square. But third number should be a product of 2 prime numbers. 120, 144, like these are not possible. Total I should get sum of the powers. I should get 3 different prime numbers. 3 different prime numbers I should get. 3 different prime numbers I should get. And it should be equally distributed. Very logical questions, sir. This is how the questions are framed. This does not involve any formula based things. It's a pure logic driven. I hope you have understood the logic. Any doubts in this logic, kindly mention in the live chat. Kindly mention it in the live chat if it is clear to you. If it is clear to you, kindly mention. 12100 is 11 square into 10 square. 10 is 2 into 5. So 11 into 2 can be given to F1. 2 into 5 can be given to F2 and 11 into 5 can be given to F3. Each one thinks about a number which is nothing but a product of two different prime numbers. I hope the idea is clear. Kindly reply in the live chat if it is clear to you. Okay, water bottle bettu Praveen. Is this clear to you? Kindly reply in the live chat. Effective from today onwards, all the live classes will be made private. Only a part of the class will be made public, that too after few hours. But the entire class can be watched only by enrolled students. Only by enrolled students can watch the entire class. We work with a model similar to Hotstar. You watch the cricket match for 15 minutes. To watch the entire match, you have to pay for the subscription. As simple as that. Idea clear, right, everybody? Next question. Now, please write down Wilson's theorem, another important model. Wilson's theorem. It takes 15 to 20 minutes to discuss Wilson's theorem problems. Wilson's theorem helps us in finding the remainder when a numerator is divided by a denominator and a denominator prime number. Wilson's theorem is used when the denominator is a prime number. Wilson's theorem is used when the denominator is a prime number. Right? Ramesh, there is a number visible on the screen. Please WhatsApp that number right now. We will discuss after the class. 805 00067891. WhatsApp stating your interest for the course. I myself will call you after the class. Now, numerator by denominator when the denominator is a prime number. Wilson's theorem is used when the denominator is a prime number. First write down the concept. Reminder when p minus 1 factorial plus 1, when you divide by p, it is 0 when p is a prime number. This is the theorem. Reminder when p minus 1 factorial plus 1, when divided by p, remainder is 0. P minus 1 factorial plus 1, when divided by p, remainder is 0 when p is a prime number. Example, p is 5. If p is 5, 5 minus 1 is 4 factorial. 4 factorial plus 1 divided by 5. 4 factorial is 24. 24 plus 1, 25. 25 divided by 5. Remainder is 0. If p is 7, 7 minus 1, 6 factorial. 6 factorial plus 1 divided by 7. 6 factorial is 720. 720 plus 1 is 721. When you divide by 7, remainder is 0. Please make a note of it. Reminder when p minus 1 factorial plus 1, when divided by p, remainder is 0 when p is a prime number. Another important catch in this Wilson's theorem is valid when the numerator and denominator are co-prime to each other. Co-prime to each other means their HCF should be 1. P minus 1 factorial plus 1, when divided by p, remainder is 0 when p is a prime number. I hope the idea is clear. Now we will do examples one by one.